Hey everyone, welcome back to the channel. Thank you so much for the incredible support on part 1 and part 2 of this exploratory data analysis project using advanced Python. Your encouragement has been amazing. Today, I'm excited to present part 3, the final chapter of this project. In this video, we'll wrap things up with in-depth insights, advanced visualizations, and final observations using Seaborn, Plotly, and Matplotlib. It all comes together here. If you haven't watched the earlier parts yet, make sure you check them out first. And don't forget to like, comment, and share and subscribe. Let's dive in.
And taking out the info, we can see we have, after the column genre, we have action, animation, comedy, crime, and so on and so forth for each of the genres available. And lastly, we'll be having on the 33rd index, we can see production countries will be continuing the original dataset columns. Starting with the next part, since we have created one for the genres column, we are going to create this same kind of structure for the production countries, as well as it is also having a form of list type values, and we are supposed to create each and every country based column for knowing if the title or the belongings of that particular content is from one particular country or multiple of them, or they are actually channelizing their content into multiple countries or one of them. So this will make us very clear about taking out the insights based on the regional content. So we have done the same for this one, and as you can see here, we can see that columns are generated, and after finding out the info, we can see that it has been a lot of columns available, which is 148 will be having object type, N64 will be 3 columns, 464 will be 4 columns, and for the datetime column will be 1. So you can add them up. That will be a count of 156 for each of the following columns in this data set. So talking about the manipulations that we have done and the insights that we have found is we have performed the data cleaning, and we have changed the data types of the required columns, like the release year column, and then we have merged the data set. We did it previously and based on the common primary key, and we have taken the actionable and useful insights with much ease. Now the transformation of the dataset was done by introducing more columns having the bool values instead of the limited columns having list based values or the duplicated data elements. Fifth part is that we have introduced new columns based on the bifurcations of the details regarding the credits of the characters, which is a credited column. Next is removing the duplicates and filling the null values based on the requirements. This is bottom-up approach that I've written here for the manipulations that I've done. And lastly, we can see if the null or duplicated values still exist. So we have checked for each of them, and we now have this surety that none of them are repeated or none of them are null. Starting with the visualization. Alright, so starting with the visualization, we have number one will be the correlation heat map. The first chart that we'll be talking about is the correlation heat map. What we have here is we have created a heat map for this particular insight, which is average IMDb score by genre, and we have all content here. As you can see, we can look at each of the score, which will be having the highest in the yellow color and the lowest in the purple or violet color. So this is the whole heat map type structure for taking all the genres by content. As you can see, we have a type based filter available. So if we talk about movies, we'll know that how many movies from which genre are having more IMDb scores and what are the scores available for them. which genre movie is having the least score available for that, and we can do the same for the shows as well, and we can do the same for both of them, selecting both of them as well. Moving on to the next plot, which is the scatter plot. So as you can see, the scatter plot is made between the IMDb votes and scores. So similar kind of plot can be made between the TMDB votes, that is popularity, and score as well. So we are taking, for this instance, we are going to take only the IMDb votes and scores. So here the scatter plot is going to demonstrate how the particular votes are varying with the scores. So what are the scores that have the most densely populated popularity, and this is what this particular visual is actually explaining very well. So if we want to only learn about the particular votes that are under the range of 100 and are varying up to 10, so we can auto scale this particular visual by using this particular button. We can select the area that we want to visualize very densely, and here we can get the answers. So this is how the scores are varying based on the popularity or votes. So up till 100 votes, most of the votings are present in the areas where the score is between 9 and above 2, and the most density is here at 6.6. So we can say that the more votings, around 100 plus votings are here in the area where the score is 6.6. That means the people who mostly the people have given score to be 6.6, 6.5 to 6.6. We are able to determine the votes and the density of scores very clearly, how the score ranges are varying as popularity is increasing. So moving on to the next plot, we can make it auto scale back to like this. Next point is,
so jumping on to the third visual, which is a line plot. So for this line plot, what we have done here is we have taken out the average of IMDb score against the year, that is a trend type plot, which will give us the average IMDb score of movies and shows for Amazon Prime by year. So as you can see, we can see that in 2020, in 1920, there has been a very vast variation between the content types score, whereas we can see that it is varying by year. And by 2020, we have the maximum rating to be 6.5 on Amazon Prime Video. So this can be done to the TMDB rating as well, but we have currently used the average IMDb score by year, so we can do the trends analysis for the other score, popularity, and votes as well. Talking about the fourth chart, which is the horizontal bar chart, which is created for the top 10 most popular TMDB and IMDb rated movies and shows. So we have the 10 most popular titles based on the IMDb votes, as well as we have top 10 most popular movies by the TMDB rating. So for both the visuals, what we have done here is we have taken the different type of visuals, in which one is based on the top 10 most popular movies only, taken out on the basis of TMDB popularity, and the other one is the top 10 most popular titles or movies, or which has both the movies and the shows based on the IMDb votes. Moving on to the third Moving on to the fifth visual. Moving on to the fifth visual is a pair plot where you can see that we have the determination of the regional content availability correlation, which is going to showcase the particular regional availability of the contents and the creation of the regional content. So you can see the bar graph is not showing very um, presentable material, as we do not have much of the contents available from the other countries. Most of the content is created and available by the US itself. Talking about the next plot, which is a donut plot, which is created over the data of the content types and is going to show the dominance of which of the content types on Amazon Prime Video is available. So we can see that the shows are having less dominance as compared to the movies.
Lastly, we are going to talk about the last and the final visual, which is vertical bar plot with toggle switch. So here in this visual we have the top genres on Amazon Prime Video, which are distributed based on the genres available, and we can see the count of those genres to understand which of the following genres are watched more on Amazon Prime Video. We can also use the toggle button to switch the numbers and understand which of the particular type, which is show or movies, does have more number of viewers or more number of watch list. So here you can see the topmost genres for shows is 2157 and the top genres in movies is 24703, which is 24,703. So here we come to the end of our visualization. Moving forward with the solutions of the business objective. So to understand what do we suggest the client to achieve the business objective is, we can see that to help Amazon Prime Video achieve its business objectives, we need to know that the increasing viewer engagement or retention and the market share are supposed to be varying as per the dataset. So with this dataset and the visualizations that are created, we can take out the strategic insights, we can guide the targeted actions. Firstly, we have done the genre analysis where we have done the types are actually watched by what number of people. Secondly, we have the content type distribution, which has the power of making the audience understand what type of movies or shows are dominant. And the next thing that we have here is IMDb scores, which are going to be presented in the form of trends analysis for the same. And lastly, we are going to take the popularity metrics for the IMDb and TMDb. So in summary, by rebalancing content type, genre diversity, quality focus, and recommendation intelligence, Amazon Prime can drive sustainable growth and deeper viewer loyalty. Talking about the conclusion, so the EDA project was actually aimed to discover the key insights from the Amazon Prime Video dataset to inform strategic business decisions related to the content production, acquisition, and user engagement. Key learnings were basically, how did the analysis reveal that the Prime Video's content library is predominantly composed of movies with comparatively fewer shows? How do we know that genre distribution showed a high concentration in drama, comedy, and action across all the other content types that we had? Insights from the IMDb scores and votes indicated that while some highly visible titles gained significant audience traction, their quality as measured by IMDb scores did not always correlate positively. And temporal analysis of the IMDb scores across the years showed minimal improvement or decline, suggesting that the potential stagnation in the content quality. Popularity metrics from the TMDB and IMDb also helped identify the top performing titles that indicated the genres and content type currently which drive the platform traffic. So we had certain challenges that were faced, like we had a different type of data type for the year-based column, so we had to create a new column for that. We had genre and the population country column, which did not have the proper values but had values in the form of in the data type of list, and we could not create better insights from them, so we had to change the whole column structure into such a way that we had to divide each of the entries one by one and create a column for the same, having the Boolean values for the distribution. And also lastly, we had to eliminate all the duplicate values and check for the null values if present. Also, we had to fill in the null values which were there in the numerical columns, such as IMDb scores, IMDb popularity, TMDB popularity, IMDb score, IMDb votes, and TMDB scores. So for them, we had to fill into the null values by using the stats operations, which were mean and median. So the achievements that we have done is, so despite the challenges, the project was successfully built, having multiple visualizations made on Plotly and Seaborn to illustrate genre popularity, IMDb score trends, and content type distribution. So the interactive dashboards with drop-downs also allowed dynamic data exploration. The insights derived are directly actionable, for example, by identifying the underutilized genres or highlighting the mismatches between popularity and critical reception. These findings can support data-driven decision-making in content strategy, marketing, and product development on the platform. So overall, the project demonstrated effective use of the Python-based data analysis and visualization, and we had different visualization tools to extract the meaningful business intelligence from the streaming platform data. Thank you.